Hello, my name is Madison Sig, and my project is the effect of land use on water quality. In this experiment, I tested to see how land use affects the quality of the water of Rock Creek. Rock Creek is upstream of the Chesapeake Bay, so what happens in our water will end up contributing to the water quality of the Chesapeake Bay. We need to restore the bay to help save it and its resources. If the testing site of the stream is changed from rural upstream of the wastewater treatment plant, downstream of the wastewater treatment plant, and downstream rural that has passed through the town, then the chemical parameters that indicate stream health would be in the healthiest range upstream rural because as the water is moving downstream into the city, the stream may pick up more waste and pollutants from the land use and other merging streams as it travels through the town. The independent variable for this experiment is the location along the stream that is being tested. The dependent variable that will be measured are the levels of dissolved oxygen, nitrates, pH, water temperature, conductivity, and water transparency. DO and nitrates will both be measured in milligrams per liter. pH, according to the logarithmic scale from 0 to 14. Water temperature will be measured in degrees Celsius. Conductivity will be measured in microsiemens per centimeter, and water temperature will be measured in centimeters. The control for this experiment is the day all the testing will take place, the time the tests are collected, and how the samples are collected and tested. This is a FieldScope map of the stream sites I tested. I was originally going to test different sites along Conewago Creek, but it was very hard to access those sites. So after consulting with Miss Bird from Gettysburg College and Advancing Science, I chose to evaluate Rock Creek instead. Miss Bird trained me as well as my class on how to use GLOBE protocols and the equipment. Mr. Toth trained Miss Bird and my teacher on GLOBE protocols and data entry on the GLOBE database. This is Site 1, downstream rural. It was shaded and had a vegetated bank and limestone bedrock. This is Site 2, downstream of the wastewater treatment plant. It was shaded, had a vegetated bank, and muddy, rocky stream bed. This is Site 3, upstream of the wastewater treatment plant. It was slightly shaded and had a vegetated, muddy bank. This is Site 4, upstream rural. It was shaded, had a vegetated bank, and rocky, muddy stream bed. Dissolved oxygen is the amount of oxygen that is dissolved into the water. It is important because without oxygen, the organisms in the stream wouldn't be able to breathe and would die. Conductivity measures the amount of electricity conducted through 2.54 centimeters of water. Conductivity is important because it tells how many different particles are in the water. pH is the measure of the concentration of hydrogen ions in a solution. pH values of 7 are neutral and are good for stream life. Low pH values are acidic, high pH values are basic, and these levels can be harmful to organisms in the stream. Nitrates are a form of nitrogen, which also include ammonia and nitrites, which are essential plant nutrients. Organisms produce waste, which turns into harmful ammonia, which bacteria breaks down into nitrites, which are also harmful. Then the nitrates are broken down by bacteria into nitrates, which are not as harmful. If there are too many nitrates, then many plants grow. Sunlight can be blocked or nitrates can run out. The plants begin to die and fall to the bottom of the stream. Decomposers start to break down the plants, using up all the dissolved oxygen, and then a dead zone occurs. Water temperature influences the diversity of the aquatic life in a body of water because different organisms can survive different temperatures. Water transparency measures the clarity of the water, which is important because the clearer the water, the more sunlight can reach all the plant life, even at the bottom of the stream. Water transparency was measured using a homemade transparency tube following GLOBE protocols. This graph shows dissolved oxygen levels of Rock Creek using the HAC oxygen dissolved kit. Dissolved oxygen is increasing over the testing period. This graph shows the nitrate levels of Rock Creek using the HAC nitrate kit. The nitrate levels are decreasing except for Site 4. This graph is showing the nitrate levels of Rock Creek using the API Freshwater Master Kit. Using the pH level, this graph shows the pH levels of Rock Creek using the Vernier pH sensor. pH starts off slightly basic but becomes more neutral during the testing period except for Site 3 during week 4. This graph shows water temperature levels of Rock Creek using the temperature probe. Water temperature decreased over the testing period. This graph shows the conductivity of Rock Creek using the Vernier conductivity probe. Conductivity increased very slightly over the whole testing period. This graph shows the transparency levels of Rock Creek using the transparency tube. Transparency levels slightly increased as well. This comparison graph shows dissolved oxygen and water temperature of Site 1. This comparison graph of nitrate and conductivity at Site 1. As the nitrate levels increase, so does the conductivity for all sites. This comparison graph shows conductivity and transparency at Site 1. As conductivity decreased, the transparency increased for all sites. This is the comparison graph of dissolved oxygen and water temperature for Site 2. The comparison graph shows that the dissolved oxygen increased with the temperature when the temperature decreased for all sites. Even though all the testing sites had very good water quality, the results support my hypothesis that states if the testing site of the stream is changed, then the chemical parameters that indicate stream health will be in the healthiest range upstream rural because as the water is moving downstream into the city, the stream may pick up more waste and pollutants from the land use and other merging streams as it travels through the town. Rock Creek is one of the major creeks flowing into Marsh Creek, which flows into the Monocacy River, which flows into the Potomac River, which flows into the Chesapeake Bay. So essentially, the water quality of Rock Creek has an impact on the Chesapeake Bay. The land around Site 1, mainly deciduous forests, low-intensity developed, and woody wetlands. The land around Site 2, low-intensity developed and cultivated cropland. The land around Site 3, deciduous forests and low-intensity developed grassland. The land around Site 4 is deciduous forest and low-intensity developed. The land around Site 1 has a population density of 0 to 400. The land around Site 2 has a population density of 0 to 400. The land around Site 3 has a population density of 0 to 400. And the land around Site 4 has a population density of 0 to 400. Future experiments for me are to extend the testing period and process and seeing if the results kept the same consistency over a longer period of time or throughout the changes in seasons specifically involving weather events such as snow. Other changes in farming practices over the seasons. Testing the effect of other water quality parameters and macroinvertebrates to set a long-term picture of health of the creek. Other creeks in the area would be monitored as well to compare Adams County creek health. Rainfall tracking, pH conductivity and transparency correlation, blast tracking of nearby quarry, discharging data from the wastewater treatment plant, alkalinity, pH and geology correlation, statistical analysis, map of rocks and minerals upstream. If experiment were to be repeated, done consistently 2 times a week for a month to see the changes throughout the month. After becoming comfortable with GLOW protocols, I became a student trainer for the other students in my class, as well as grades 6 and 7, who learned to use the protocols and equipment for the class hydrosphere investigation. I used many references in my background research and to help guide me in creating my conclusion. Thank you for taking the time to listen to my project on the effect of land use of water quality.